Vanakkam. Welcome to this video on classics in neuroscience. We have been looking at the chemical signaling molecules, or the first neurotransmitters in the brain. We continue the discussion. In this video, we will be looking at two topics. First is the concept of lock and key, or something like a lock and key, some specificity mechanism between chemicals, and how acetylcholine was discovered using pharmacology performed at the level of organs. Remember, acetylcholine is a molecule, studies are happening at the level of organs, and how even using studies at the level of organs we are able to understand the action of acetylcholine. So, the first models or the earliest models for molecular activation came from enzymes that were acting on their substrates. The first experiments were performed by using sugar converting enzymes in the 1890s by Emil Fischer, Germany. Where he suggested that the interaction between an enzyme and a substrate is similar to a lock and a key. That is, for example, in a lock there is a space where a particular key can go, and only that key can open that lock, and that key usually cannot open any other lock. So, there is indeed a one-to-one correspondence between the lock and key. It better be that way. In a secure lock, that is what would happen. Similarly, between an enzyme and a substrate, you are going to have something like a lock and key mechanism. A one-to-one correspondence was suggested by Emil Fischer. Based on this idea, Paul Ehrlich developed this concept of molecular nucleus with side chains binding to specific and distinct antitoxins, leading to specificity in the immune system. Distinct antitoxins in the immune system, very similar to the original sugar converting enzyme example given by Emil Fischer. This idea of lock and key became popular as an example or an example model to explain reactions in biology. Although this was present in biology in general, but the idea that the chemical signaling molecules, that is the neurotransmitters, and the receptive substances and the receptors were acting similar to the lock and key mechanism was not apparent in the 1890s or the early 1900s. This was not clear. This idea was to catch up much later, and it was to happen only in the modern era, that is in the 1940s or the late 1940s, 1950s. Only at that point in time this idea was to catch up. So, in the early 1900s, pharmacology was studied at the level of organ level, that is chemicals were introduced at the level of organs and response was studied at the level of organs. Remember, John Langley and his students and their experiments created plenty of excitation or excitement in the scientific community, especially among biochemists and those who are interested in neuroscience, to identify these chemical mediators and receptive substances. But they were not able to identify the specific molecules. There was a grand struggle in the period between say 1900 to about 1930, 1940, even 1950 towards identification of this. That was not because there were not good experiments or good questions that were being posed, but rather experimental methodology was lagging behind because the experimental preparations were at the level of organs. This was a major limitation towards identification of these molecules. An early exception to this was the identification of acetylcholine by Walter Dickson, I think 1907, and Henry Dale 1914, where it was demonstrated that acetylcholine is a chemical mediator, and two different effects were demonstrated. That there was a rapid effect that was mimicked by nicotine as it happens as in the neuromuscular synapse, and something that slows down, a slower effect, neuromuscular junction, a rapid effect as in nicotine as that happens in neuromuscular junction, and a slower effect as that found through muscarine like in the vagus nerve stimulation. And Otto Loewi in 1921 in a classic experiment showed that if you stimulate vagus nerve, there was slowing down. This was already there, this kind of experiment was already performed, but Otto Loewi, there were two hearts. One stimulated to release a chemical, a substance, which is acetylcholine, that then perfuses through the liquid and acts on the other heart to slow down the other heart. Otto Loewi called this chemical as some vagus stuff. He gave that name. That chemical that slows down the vagus nerve as vagus stuff. This was the name that was given by Otto Loewi. This suggested there was indeed chemical transmission involved in between cellular, intercellular signaling in excitable cells. A very important milestone for this field. Edgar Adrian and Charles Sherrington suggested that there were some substances that were inhibiting function that they called as inhibitory neurotransmitters. This idea suggested by Edgar Adrian and Charles Sherrington. Meanwhile, Dale and Feldberg suggested that acetylcholine was released in all parasympathetic neurons, and Henry Dale went on to make some specific definitions, terminology. He called those neurons that released acetylcholine as cholinergic, and those neurons that released adrenaline as or adrenaline like sympathin. He called adrenaline like sympathin. Those neurons that released adrenaline like sympathin are called adrenergic, and those neurons that released acetylcholine were called cholinergic. And those sensitive receptors that were sensitive to acetylcholine were called as cholinereceptive receptors, and those that were sensitive to adrenaline were called as adrenoreceptive receptors. However, this terminology has not stuck on. Rather, what is now found is cholinergic receptors and adrenergic receptors. So, these kind of examples of early experiments, acetylcholine and adrenaline, and the receptors for acetylcholine and adrenaline was to set the benchmark for future chemical mediators and receptive substances. What are these? neurotransmitters. Chemical mediators means neurotransmitters, and receptive substances means receptors. This set the benchmark for future identification of such substances. With this, we come to the end of this video. In this video, we looked at the concept of lock and key, and we saw some examples of lock and key mechanisms in biology, specifically in enzymes and their substrates, and between specifically we saw the examples of enzymes and their substrates, and another example in the immune system. We also saw the use of pharmacology at the level of organs and how that was used to identify acetylcholine and receptors that were sensitive to acetylcholine or cholinergic receptors. So, with this we come to the end of this video. Thank you very much for your attention.